students throughout. So for the session, as you know, dear colleague, this session is on Save the Environment, Go Green with the Chemistry. So as from the title, the green chemistry starts with the concept of invention and design. This means we scientists and technologists must take into account from the start what we are looking for, what kind of product, how we are going to design its manufacture and its use. The impact of chemical products and chemical process must be included in design criteria. Besides, hazard consideration for initial materials and final products must also be included in the performance criteria. In this talk, the resource person will briefly introduce the requirement of green chemistry for sustainability, better synthetic routes focused on cleaner production techniques, and less toxic consumer products will be discussed. So I may invite Dr. Priyanka Sharma to start the talk, but prior to that, I may kindly request all the participants to mute your mic and also keep your camera in off mode. However, we encourage all the participants to ask a question. So I may kindly request all the participants, if you have any question, please drop in the chat box. We have highly dedicated faculty members led by Dr. Renu Chaudhary. She is coordinating this session. So our faculty members will note it down, all the questions you wanted to ask the resource person. And at the end, we will open a house and you have our faculty members, or we will they will unmute you, request you to unmute your mic, and you have possibility to ask your questions. Besides that, you can ask any other question relevant to this talk. It is not say mandatory to absolutely stick there. So closely related could be say asked such kind of the question, and we will try our level best to reply your queries. Thank you so much indeed. And Dr. Priyanka Sharma, madam, I very warmly welcome you to initiate this session. Please come.
Thank you so much, sir, for the wonderful introduction. Good afternoon, everyone. Welcome all of you in the third session of Online Student Development Program, Go Green with Chemistry, Save the Environment. So as we all know that our life, every day we start with the chemistry, the chemical products we are using. We cannot live without the chemical products. So if we are talking about the chemical products, if we are talking about its manufacturing, if we are talking about its routes for the synthesis, then how we are able to save the environment, because those manufacturing may lead to the degradation of the environment. So with these points, I'm going to cover in today's talk. The key points are what is the need of chemical manufacturing, what is the need of sustainability and how it is related with the green chemistry, then what are the various aspects of the green chemistry, what are the principles of the green chemistry, that means what are the synthetic routes which we can design. Then we will talk about a few examples where we have applied the synthetic green synthetic routes. Then we will discuss about what are the uses of green chemistry. Then I'll take you through the tour of GDG. So first we will start what is the need of chemical manufacturing. As I started and as I said that our daily life cannot live, we are not able to live without the chemicals. So when we wake up in the morning, we use the chemical, and till the end of the day we use the chemical. So many chemical industries are working, and they are actually because of the need of consumers, because of the need of the improvement of livelihood, the production of these industries are increasing day by day. So these industry deals with the fiber synthesis, they deals with the plastics, they deals with the various medicines and drugs which are synthesizing the dyes the coloring industries like paint industry, etc., with this fertilizer industry, pesticide industry. So we cannot live without these many industries. And because, as I said, that because of the increase of consumerism, because of change of the livelihood, because of the change of our living style, the need of these chemicals are increasing. So if the need is increasing of these many chemicals or the product, then what is happening with our environment? That if we are talking about these manufacturing plants, that may leads to the formation of a large or huge amount of waste. So if that waste is generated, where we are dumping it off? We are dumping that onto the land or into the water. Maybe it is interfering with the air. So those unit is actually affecting our, we can say a complete ecosystem is getting disturbed. So if I talk about any chemical manufacturing which we are doing in the laboratory, as I said, that a large amount of waste is getting generated, which leads to the pollution in the air. With this, we can say a large amount of mixtures can be formed. We required non-renewable resources for the heating purposes. We required the catalyst also. But when we compare it with the natural processes, those processes are highly specific. That means what product you require, that will nature give you. Say, for example, if we talk about steroids, if we talk about hormones, if we talk about some of the alkaloids, terpenoids, pigments, etc. So we are, if we are talking about the natural processes or the product which are synthesized in the living organism itself, they are highly specific. We are getting very pure product. So we don't get the waste. Then why we are going and we are looking for means why we are means how we can reduce the waste which is generated from the chemical manufacturing plants. So for that, firstly we'll talk about the sustainability and how we can link up with the chemistry. So sustainability, if we need to define with respect to the environment, we can say always that whatever resources we are using, that is natural resources, should be available for the future generation. That means we have to use the rationalized amount of the natural resources so that it can be available to the future generation also. So if we want to attain the goal of that sustainability, then we have to look for the green chemistry, which is the integral part of industrial ecology and which can attain the goal of sustainable development. So industrial ecology, if we talk about, we can say the industrial ecology is the various stages of the production of the goods and services from goods or services which can interfere with the natural resources. Right. So if we are talking about the green chemistry, so green chemistry is the integral part of industrial ecology for the sustainable growth. So we have, if you are talking about the sustainable development, all the manufacturing units, that is chemical manufacturing units, the research laboratories, the academic institutions should follow the various principles which is governed by the green chemistry. So when a term came into the light, so this term was proposed in 1990 after the Pollution Prevention Act come into the light by the Environmental Protection Agency. The Paul-T. Anastas was the father of the chemistry. He introduced this term in 1991, whereas it was said that in 1978, the Dr. Kleitz had said that we require some alternative routes or the pathways for the synthesis of or for the chemical transformation. The Paul Anastas has defined the green chemistry by saying the statement that the green chemistry is the group of technologies which deals with the invention, design and application of chemical products and processes to reduce or eliminate the use of generation of hazardous substances and the possible utilization of the raw material. So what is a green chemistry? Means how or what is we are talking when we are talking about the green chemistry, what we have to discuss. So as we are saying that the chemical products which we are using, which we are forming, or the materials which we are using, or various intermediates which are formed, or for any chemical transformation, we require lots of chemicals. So the clean chemistry is about to reduce the waste. That means in any chemical transformation, if more than one product is forming, then whatever we require, the target molecule, the maximum amount of target molecule has to be formed. That means the side product or byproduct should be avoided. That means that is waste for us. So we have to reduce the waste which is generated by the chemical transformation. The material use has to be reduced. That means that means we should have the 100% amount of the material, 100% amount of the product we are getting from the reactant. Try to get it. Then reducing the hazard. That means if any transformation is giving you the toxic material and it will be, if it is harmful to the environment, ultimately to the human being, then we have to reduce the risk of the formation of the hazard. Then during this transformation, if some leakage is there or something like that, that also has to be reduced. In fact, the energy that we are using, the amount of energy which we are using, that is from the non-renewable resources, that amount also has to be reduced. And whatever synthesis we are doing, whatever transformation we are carrying out, the cost of that process should be reduced. So in this presentation, we'll talk about the various aspects of the green chemistry, that how we are able to attain the goal of sustainability with the help of the green chemistry. For that, we have to talk about the catalysis, we have to talk about the solvent replacement, we have to talk about what are the raw materials which we can use, how we can prevent the waste generation, how the efficiency of the process can be amplified, how energy efficiency, the process which we are talking about, how we can increase the efficiency, how we can do the process, that is separation processes, most cost effective, and what are the reactions or reagents we can use to accelerate, we can say, the sustainability goal. So Anastas and Warner has given 12 principles for the green chemistry, which deals with the prevention, the atom economy, less hazardous chemical synthesis, designing of safer chemicals, the use of safer solvent and auxiliaries, the designing of energy efficiency, renewable feedstocks, reduce the derivatives, use of catalysis, design for degradation, then real-time analysis, and the accident prevention. We will discuss all the principles now. So first principle of the green chemistry says prevention. As we all say that prevention is always better than cure. Similarly, for any chemical transformation, we can say we have to prevent the waste generation, then to clean up the waste after forming. So we have to choose that chemical transformation which can reduce the generation of the waste or minimize which can reduce the waste generation or can completely prevent the waste generation. Because if waste is getting generated, then we have to treat, this is the first problem. Another problem is waste is generated, then we have to dump it off somewhere. If we are dumping onto the water, it leads to the water pollution. If we are dumping onto the land or onto the soil, it leads to the respective pollution. In fact, the gases which are liberated into the air, that may also lead to the pollution. So we have to look for the alternative ways so that the waste reduction we can attain. So this is one of the case study of Love Canal, where the plastic industry was dumping the waste into the land, and after some time that land was used for the school and the housing track. But after some time it was observed some of the gases are liberated from that dumping site, around 82 chemical combination that is liberated from the dumping site, and that leads to the high birth defect and various nervous diseases problem. The another principle of green chemistry is saying that we have to look for atom economy, not the percentage yield. What does it mean? That whatever final product we are getting, that should have maximum of reactant material. That is, all the atoms which are taking part in the chemical transformation should completely transferred into the final product. So more is the atomic economy, then we can say the green route is more efficient route. So if we have to define the atom economy, we can say the percentage of atom economy is equals to formula weight of atoms utilized divided with formula weight of all reactants multiplied by 100. So if we have to define this principle, I have taken here the example of epoxidation of styrene. So the styrene molecule that converted into this epoxide. If we'll talk about the percentage yield, this is 100% because by the reaction with this peroxide, we are getting this epoxide with the elimination of a side product, that is the metachlorobenzoic acid. But if we'll talk about the atom economy, we can say it is only 23%. That means the metachlorobenzoic acid which is formed during this transformation is waste for us. So we should avoid this type of route where atom economy is less. So we have to look for the alternative pathways where atom economy can be improved. The third principle of green chemistry says that any chemical synthesis which we are doing, the methodology which we are using should follow or should use less of the hazardous substances. Which that means it should not affect the living organisms, it should not affect the environment. So that should be as minimized as possible. Say for example, here is the synthesis of polycarbonate. So here for this polycarbonate synthesis, we have used the material phosgene. One of the reactant is phosgene. And we all know this is quite toxic substance, very corrosive substance. So instead of that, some alternative pathway has to be applied, and we have chosen the solid state process where the polycarbonate synthesis was carried out with the use of within the solid state process. So that route we are not using the phosgene, and another thing is we eliminate the use of the dichloromethane. The fourth principle of green chemistry says that designing of safer chemical. That means whatever product we are getting should be of less toxic, or for this conversion, whatever we are using should actually less poisonous, should not affect the environment. Right, so that means that possess less harmful or that should be less toxic product. Say for example, when we are in the literature, it was mentioned that polystyrene manufacturing is carried out by chlorofluorocarbon, and we know this is the basic source of ozone layer depletion. So instead of CFC, it can be replaced by CO2 for the greener route of synthesis of polystyrene. The another principle of green chemistry says the use of safer solvent. That means or any auxiliary substance which we are using. That is any separating agents. If we talk about any solvent we are talking about should be safer. That means that should not affect the environment as well as the living component onto the in the ecosystem. So this was the list which was proposed. So here you can see in the green all the these are the green solvents which we are using, which are preferable over the other reagents, other solvents which we can use for any reaction transformation. So this was the case study proposed by the Pfizer, to where they have actually used the solvent replacement guide, and they found that there is a reduction of 50% of fluorinated solvent in complete research division. In fact, they also observed that the desirable ether reduction, the use of that is also reduced till the 97% within the 2 years of period. Another principle of green chemistry says that the use of renewable resources or renewable raw material. So we have to use those raw material which are biodegradable ones. If you say that something is degraded, that doesn't mean that you can use it, because that may lead to the some of the material which can be toxic to the environment, because for that degradation you require some processes that may lead to the product which are may be toxic to the environment. So this is one of the commonest example where the PLA, that is polylactic acid, we use for the plastic production, and PLA we synthesize from the natural product that is starch. So corn, from that we extracted the starch on fermentation. It convert into the lactic acid. This lactic acid, when we do the polymerization, resulted into the formation of polylactic acid, and this polylactic acid on polymeric processes or on by the conversions, various conversions, converted into various form of the plastic, like film, like thermoforming, like bottle, etc. Similarly, we can choose other feedstock also, like paper mill sludge, we can use for the transformation to get some starting materials. We can choose the agriculture residue or the waste root. We can use the municipal solid waste and the waste paper. From that, one of the material which can be extracted is the libulinic acid. This libulinic acid is the starting material for various other transformations. You can see here that this libulinic acid is converted into some of the useful chemical compounds like succinic acid, converted into methyl tetrafurane, that is the fuel additive. It convert into tetrahydrofurane, it convert into acrylic acid, and so on. So this one of the compound can be act as a initiator or the precursor for several other transformations that can be attained in the chemical industry. Then another principle of green chemistry say that we have to reduce the derivative. What does it mean? That whenever we are doing any chemical transformation and we are using the starting material, that starting material may be having more than one functionality or more than one active center. So in the chemical synthesis or in the synthetic laboratory, what we do, we block one of the end of that molecule so that another the functionality can react. So if we are choosing this mode of transformation, if we are choosing this way, then we can say there is a loss of chemical during the process. Okay, we are wasting the material during this transformation. This temporary modification requires lots of chemical, lots of effort, lots of time. And as well, the waste is also getting produced. So that is going to affect the overall yield as well as the atom economy also. So if we are designing any synthetic route, if we're designing any chemical transformation, we have to choose the methods which reduce the formation of derivatives, which do not use actually the blocking or the protecting of the function group. Another principle of green chemistry says the use of the catalysis. So we know catalytic reagents are used or catalysts are used to increase the reaction rate. We can say it is used to increase the yield also, and we are able to make the reaction more feasible, and there would be better utilization of the starting material or the raw material. So nowadays we are looking for the catalysts, which are the black catalyst or the green catalyst, because it was found that the bad catalysts which we are using are actually, if you're talking about the yield will be very high, because those catalysts are having the correct orientation, and because of that correct orientation, the yield will be very high. The reactions will be highly stereospecific, and we know the bad catalyst, that means these are the naturally occurring, that is the best thing that we can say. And with the help of bad catalyst, we are able to attain the one-pot synthesis. That means we are actually reducing the time for the reaction. We are reducing the waste which is generated during the process, so that we are also reducing the energy consumed during the chemical transformation also. So that means we are saving the environment. Now, the ninth principle of green chemistry says design for degradation. That means whatever product we are trying to get, that should not persist in the environment. Whatever we are synthesizing, whatever chemical transformation we are doing in the industry or in the laboratory, anywhere, the product should be degradable one. Why it is so? Because if your product is not biodegradable, then it will enter into your food chain, and the amount of that will be increased. The concentration of those substances, those toxic material will be increased as per successive level in the food chain. So that leads to the phenomena that we all know, bioamplification or the bioaccumulation. So most common example, if we'll talk about, that is of non-biodegradable material which was synthesized earlier. Now these are prohibited, like DDT. We all know about the case study that DDT is non-biodegradable one. Once it enters into the food chain, its concentration will increase in, as we move from one level to the another level in the food chain. So we have to design a product which should be biodegradable one. Say for example, polylactic acid. Now another principle say the real-time analysis for pollution prevention. So whenever we are doing any chemical transformation or the synthesis in the laboratory, then what we are doing? We are monitoring the reaction. If we are monitoring the reaction, what does it mean? We are checking the progress of the chemical reaction, how it is happening. Once reaction is completed, we should stop the reaction. If we are not doing the real-time analysis, if we don't stop the reaction once it is completed, then what we are doing? We are wasting the time and energy also, or it may lead to the formation of some hazardous substance. So that can also be controlled if we are monitoring the process when the reaction is going on. So if you are saving the time and energy, again you are preventing your environment from the various kind of pollution which can be occur. Then another principle say the safer chemistry for accident prevention. That means if we are doing any chemical synthesis, if we are doing any chemical transformation, we should minimize the potential for any chemical accident. That means any release into the environment, any explosion that can be occur, any fire thing that can be occurred, that has to be prevented, that has to be minimized. We all know about the Bhopal gas tragedy that was in 1984, where there is a release of isomethyl cyanate in the environment from the Union Carbide factory. Thousands of people are killed and still affected from these gases which are released. So that is the one of the examples. So whenever we are planning, whenever we are designing any plant or any transformation, we should minimize the potential for any accident. The another principle of green chemistry says that design for energy efficiency. That means if you are talking about, if you are trying more than one, if you are trying to do any chemical transformation, we have to look for those synthetic routes which are environmental friendly, which use the minimum of energy. In fact, some of the alternative methods if we are used where we can choose non-conventional energy resources instead of the resources which we are using, that is non-renewable energy resources. So we should to identify the processes at what temperature pressure conditions we are able to do the reaction. Once we got the idea about the condition of temperature and pressure, then we can recognize that which of the energy resource we can use. So initially the chemical processes we were using the conventional energy resources, that is your thermal reaction, where we use the coal, petroleum, etc. for the conversion for the energy processes. But nowadays the scientists and the researchers are using the alternate energy resources for those transformation. They are using the photochemical reaction, the microwave reaction, sonochemical reaction. By those reactions, firstly, we are not using the non-renewable energy resources. That means if you are not using that, that means we are protecting the environment. Okay, those resources are available more to the future generations. Secondly, that if we are using those resources, the non-renewable resources, that leads to the release of carbon dioxide into the environment. So that may lead to the greenhouse effect. So that has to be, we are protecting, we are minimizing that thing. Thirdly, the time used for the various chemical transformation can effectively decrease, because by these microwave sonochemical processes, the time required for any reaction we can decrease. Now we'll talk about how these basic principles of green chemistry we can use for the chemical transformation, which are chemical transformation of some industrial important compounds. So this was the synthesis of acetaldehyde. Initially, the acetaldehyde was synthesized from the alcohol, ethanol, and the oxidation when carried out, the high temperature is required, which is around 675 Kelvin. A very high temperature is required. So further, because that for attaining this high temperature, there is a loss of high energy. So for that, the alternate route was introduced, that is the conversion into acetaldehyde from the ethylene. This reaction is carried out at room temperature with, and in the presence of the catalyst palladium and copper. So a large amount of energy can be prevented. The large amount of energy can be saved. Another industrially important product is adipic acid. This adipic acid is actually the starting material that you can say in the polymeric industry for the synthesis of nylon and the lubricant that you all know. Nylon is very common synthetic fiber for synthetic polymer that we all know. So initially for the synthesis of nylon, the adipic acid which was synthesized that we have taken we have the synthesis was carried out by starting from the benzene, and by benzene we are able to get the adipic acid. So we are using the benzene which is having some environmental and health issues because this is somewhat toxic, and it also liberates the nitric acid into the environment. There is a byproduct of nitric acid also. So this nitric we all know that may also lead to a greenhouse effect. So further, the another route was actually proposed, that is the synthesis of adipic acid from the D-glucose. So this is the renewable resource that you can say the raw feedstock, raw material which we are using is the renewable one that converted into the adipic acid. Further, it will talk about the disinfection of the water. So if you talk about disinfection of the water, initially it was carried out by the chlorination. Okay, when we add it, the pathogens are killed. Okay, pathogens are killed. But with this, the acid which are getting produced, that is hypochlorous acid which is getting formed may oxidize or may change the pH of the water. Right? If you change the pH of the water, then if you are talking about for the drinking purpose, that may affect actually the quality of the water for the drinking purpose. So nowadays we are using ozone as a replacement for the disinfection of the water. Now another example, that is the production of allyl alcohol. In the allyl alcohol production, you can see the traditional route is from the allyl chloride with the water. It is going as the allyl alcohol with the formation of the HCl. So HCl, we have to avoid the production of this HCl during this process. So greener route was proposed where this allyl alcohol we have prepared by reacting the allyl with the acetic acid. We did the oxidation, and finally we got the product, that is the allyl alcohol with the formation of acetic acid. So this acetic acid can further be used as a starting material for this conversion. Now, if we talk about the synthesis of ibuprofen, so we all know about the ibuprofen, which is used as an analgesic. We all know about it. We are using it since long. So ibuprofen, first synthesis was proposed, that is a traditional synthesis. Boots company was proposed in 1960, and the company said that for the synthesis they required the 6 steps, and in each and every step there is a elimination of some byproduct, like HCl is getting eliminated, HCl is getting eliminated, ammonia, acetic acid, etc. is getting removed from each and every step of the synthesis. So further, another company, BSC company, has developed the cleaner route, and they synthesize this ibuprofen only in 3-step process. Only acetic acid that you can say is removing during this process, and atom economy is found to be 77%. So this route is better as compared to the primitive route. So this was found to be green route for the synthesis of ibuprofen. Now, what are the major uses of the green chemistry? Because we are saying with the help of the green chemistry, we are able to protect the environment. So everything which is related to the environment, how we are interacting with the environment, how we are affecting ourselves. So that can also give you the idea about the uses of green chemistry. So first thing that we can say, the major use of green chemistry is in the energy. So we know if we are talking about any industry, chemical transformation industry or any other industry we'll talk about, for the energy we are using non-renewable energy resources. And those resources can damage the environment because that liberate the carbon dioxide, can deplete the ozone layer also. So we can say, yes, green chemistry is the solution of this thing because we are developing the alternative routes for energy generation. Because we can use the microwave, we can use the chemical reaction. So we can increase the energy efficiency with the catalysis as well as reduce the use of non-renewable resources. The another thing that we can say, what is the other use of the green chemistry, that is the global change. So if we talk about the climate change, if we talk about the global distillation, so those processes can also be prevented with the use of the green chemistry. That can easily be addressed. Now another use in the resource depletion that you can say. So as I said, if we choose the non-biodegradable material over the non-biodegradable material, that means the resources which are occurring in the nature if you are using, so that can also store, that can also prevent or protect our environment. So renewable resources can be made, we can say, made available as much as it is possible. So you can say in the resource depletion, you can say the use of biomass, you can say the use of solar energy, you can say the waste minimization, recycling, that you can say. So from that, you can also protect the environment. The another use that you can say is in the food supply. If we'll talk about the conventional agriculture, in that conventional agriculture, we can say we are not able to fulfill the needs of everyone. So with the help of green chemistry, we can use certain pesticides or fertilizers which are very specific as well as which are biodegradable too. So that can also fulfill what we can say that can fulfill the need of growing population size. Then the last one is the use toxic in the environment. So if we are using the green chemical routes, we can say the toxic material which we are avoiding. If we are avoiding toxic chemicals during the production and after the production, the product which we are getting are not toxic, that we can say, of course, we are saving the environment because ultimately the product which we are getting from the industries are released into the environment, right? So with the use of green chemistry, we are able to protect the environment by reducing the pollution. So we can say the green chemistry is preventing the pollution and sustaining the earth. So we require it for the sustainable growth. So we can say that green chemistry since 1991, various scientists, various researchers, government, industries, all are working together to find out the green routes so that we can attain our goal, that is of sustainable goal. So we can say green chemistry is not a solution for any environmental problem, but we can say, of course, we can prevent the pollution at least. Now I'll take you through our university, GD Goenka University. The GD Goenka University, we have got the award from various societies like IGOS, Time B School, Forbes, etc. We also provide the student scholarship scheme. So we provide the scholarship to any economically backward student. We provide 100% scholarship to the deserving candidate. Also, GD Goenka University provide GD Goenka University has an association with various universities as USA, Australia, Netherlands, France, and UK. These are the various schools at GD Goenka University. We are at School of Basic and Applied Sciences. Here our respected Dean, Professor Ramkrishnan Thakur, he is physicist. These are the faculty members of Department of Physics, and these are the research interests. They all are doing research. The basic research interest in the condensed matter, gamma ray burst, computational biophysics, spectroscopic of rare earth molecules, etc. The faculty members from Department of Chemistry. and they are working on various research areas like medicinal chemistry, coordination chemistry, organic synthesis, photosensitizer, wastewater treatment, etc. These are the faculty members of Department of Mathematics. They are also working on different research areas, diverse research area like numerical methods, linear algebra, computational and modeling, etc. These are the faculty members of Department of Biological Sciences. These are also working in various research areas like drug delivery, heavy metal decorporation, cancer therapy, etc. These are the faculty members of Department of Forensic Science. They also indulge in various research areas like forensic medicines, question documents, forensic ballistics, etc. At SoBAS, so many PhD scholars are working for research scholars are working for their PhD degree, and we are providing the PhD in various fields, versatile fields like biological sciences, physics, chemistry, mathematics, environmental science, biochemistry, microbiology, biotechnology, etc. We also able to get the research project from the Government of India DST. Also, one of the consultancy project we got. We have fully equipped laboratories. We provide various undergraduate programs in chemistry, physics, mathematics, forensic science, microbiology, biochemistry, biotechnology. With this, we have the BSc pass courses in various combinations. We also provide the postgraduate programs in chemistry, physics, mathematics, forensic science, microbiology, biochemistry, biotechnology, data science and scientific computing, geology, wildlife, forestry, biophysics, environmental science and management, and also provide full and part-time PhD program. With this, we have the postgraduate diploma program also offered by a school, that is in the criminology, in cosmetic science, in data science, in environment, health and safety. At SoBAS, we have mentor-mentee relationship. Each of the student has provided one mentor, and mentor with student can actually can contact to mentor for any kind of problem related to their academics, related to their personal matter. They can discuss. If it is not solved there, they can discuss with the HODs. If not, then they can discuss with BD. Another best practice we have at SoBAS is SIM login, from where students get the idea about their attendance, they get the idea about their marks, etc. With this, we also have various activities that is going on in SoBAS, that is various experiential learning, which is the integral part of any learning process. So in the experiential learning, we provide students various industrial visit, field visit, laboratory visit. Some of the SBTs are also conducted, workshops can also be conducted, some of the distinguished lectures, and with this, some of the conferences are also conducted. So you can see here the distinguished lecture delivered by Professor P.D. Sharma, distinguished lecture delivered by Dr. Kumar Krishnan, distinguished lecture delivered by Dr. D.K. Aswal, distinguished lecture delivered by Dr. M.B. Bardhan, expert talk delivered by Professor Ram Kumar. With this, student development program was also conducted, Creation 2020. The lecture was delivered on career opportunities and role of Bio-Incubator. With this, students are taken to various industry, like there's a visit you can see at the National Physical Laboratory, in Indian Institute of Technology, Delhi, at Inter-University Accelerator Center, New Delhi. The student visit to AIMS, the student visit at the Anveshna. With this, the various conferences are also organized. This is the International Conference on Sustainable Cities and Communities that was held in the February. In the lockdown duration, another conference was held, that is National Online Conference 2020. With this, we also believe in the outreach program. In the outreach program, we address the local public to understand local and national issues. Under this, we provide the School Connect program, teaching program for children in rural areas, blood donation camp are also organized. We invite the school and college students also at our university, visit to orphanage, plantation drive, etc. You can see here the faculty of SoBAS visited to various schools to conduct the awareness session. We also organize DST Inspire Camp. Various companies visited our university like Byju's, Genpact, Sun Pharma, etc. These are the placement detail of last year. Few students placed in various industries. So this is the website. You can visit the Facebook page, Instagram page. You can visit. I welcome you all at SoBAS. Thank you.
Thank you, Dr. Sharma, for such a nice and enlightened discussion talk. It is, I'm sure, quite helpful for all our students, attendees. And now we may request Dr. Renu Chaudhary and team if there is any question, I think.
Yes, sir. So there are few questions.
So,
yes, sir. Ma'am, first
yeah,
question
please
is from...
go one by one
Yes.
question.
First question is from Madhurita Das. She is asking, ma'am, can you please tell about atom economy again in short?
Yeah. Atom economy is, suppose if we are doing any chemical transformation, that means the reactant which we are using converted into the product. So we have two terminologies involved. One is the percentage yield and another one this one. So if you talk about atom economy, that means that the complete reactant has to chemically transform into the product. Okay. So if complete reactant is getting converted into the product, that means no byproducts are getting formed. So that means you have a good atom economy. Okay, that means the ratio of atoms in the reactant we compare with the ratio of the atoms in the product. If it is comparable, that we can say yes, the economy is very high. And it is advisable also. The high atom economy is always required when we are talking about the green routes for the chemical transformation.
Okay, good. Thank you. And Dr. Chaudhary, next question.
Yes, sir. Next question is from Ms. Bharti Dagar. She is asking, ma'am, how green chemistry help in the depletion of resources?
Can you repeat, ma'am, question?
Depletion. Yes, ma'am. How green chemistry help in the depletion of resources?
I think she meant how helps in prevention of depletion of resources. I think so she meant.
If she is here, she can
Bharti,
unmute your
if she
mic.
is here, I think it's better she asks. Bharti, Bharti, can you please unmute yourself and ask your question?
I think she is not here.
Question seems a bit, I mean, it helps in depletion because green chemistry, I think it's preventing depletion.
Hello, ma'am.
So green chemistry is, yeah.
Yes. Yes.
Hello,
Yes.
ma'am. I have a question that
Bharti, you may ask.
how green chemistry help in the prevention of resources.
Yeah, actually, if you talk about the green chemistry, we are talking about the alternative routes. Alternative routes, that means which can decrease the energy, what we can say, which can increase the energy efficiency. We are using the processes which can reduce the reaction time, and we are looking for the alternative routes, alternative energy resources we can look for. Say, for example, for any transformation, instead of thermal conversion, we can look for the sonochemical reaction or the microwave reaction. So that will reduce the time, as well as the non-renewable energy resources can also be saved. So ultimately, we are protecting the environment. Bharti, it's clear or any other doubt?
Thank you, ma'am.
Okay, thank you. Thank you, Dr. Sharma. Dr. Chaudhary, any more question?
No questions, sir.
So I
No more
suppose
questions.
someone wrote in the box about the PPT. So I think, dear participants, you can upload the PPT from our homepage. Maybe after next week, after this week, you can check our homepage and there you will find, because we usually upload on our homepage and from there you have a possibility to download. Yeah. So Dr. Chaudhary, any more question?
No more questions, sir. No more questions.
Okay. So, okay, great. So then let's thank once again to the speaker, Dr. Priyanka Sharma, for taking time out and delivering this very useful lecture for the student on Go Green with the chemistry. And also, I would like to extend thanks to all the attendees, the students, for being very patient and listening carefully the talk, and our my faculty members from SoBAS. Thank you so much for joining this talk. Along with, I also extend other external faculties, dignitaries, students who have joined this talk. Thank you so much. And do we have a flair for the next SDP or not
No, sir.
now?
No, sir. No, no. So we
At
have
the moment,
next
we do not
on
have. Okay.
19th August. Yes, sir. Dr. Priyanka Srivastava. 19th of August.
Okay, we have a 19th of August. There is a one more SDP session, another session, and I may kindly request all the attendees to join this. You may kindly check our homepage, SoBAS homepage, and there we upload the latest information at least a couple of days before. So you have a possibility to attend our another sessions as well. All the sessions are meant for the students. Besides that, we have also planned for, say, eminent scientist series, and there we have already conducted 2 sessions, and next session is a schedule on 21st, and there we have invited a professor from University of Taiwan, very senior professor, and followed by the 4th session on 28th of August, and there we have invited 2 very senior professors from IISc, and they will speak about the scope of nanotechnology. So please keep watching our session. And well, so Renu Chaudhary, you have written here that the next SDP is for will be on a crime scene survey. Okay, good. Crime scene survey. So as much as I understand, this belongs to forensic sciences. So dear colleagues, please disseminate this information among your colleagues and join the talk. This is for you. This is meant for you. So I'm sure it would be helpful. With this word, I would like to again thank Dr. Priyanka Sharma for
Thank you so much, sir.
this talk, and all the attendees. Thank you so much. Stay safe, stay healthy, and certainly stay at home. This is the demand of time for another couple of months. Thank you so much.
Thank you
I
so
wish
much.
you a nice evening.
Thank
Bye.
you,
Take care.
everyone.
Jay, God
Thank you,
bless
sir.
all of
Thank you,
you.
ma'am.
Jay. Okay. Bye. And thank you, Dr. Renu Chaudhary and Sonika Sachi, for organizing, coordinating the session. Thank you.
Welcome, sir.
Thank you, everyone.
হ্যালো হ্যালো, হ্যাঁ পাচ্ছি। তো যাই হোক, এগুলা তো মানে আমার আমার তো হচ্ছে অনেক অজানা বিষয় জানা হয়ে গেল। হ্যাঁ ছিলাম। হ্যাঁ। কি টেস্ট করেছিল? হ্যাঁ সিগারেট করেছিল মনে হয়। হ্যাঁ করেছিল। চ্যাট করছিল, এটা মনে আছে তো। মনে আছে। আচ্ছা। আছি।